guys? Why? Last time you have done something on this chair. Private paper. No, that was chair. So how about qualifications? Ashwin, how are you? Ashwin, right? Wow. ABC. What else? What else you have got? So Pradeep, Dinesh, 17 have got? No? Very heavy books. Come sit here. Achha, why is that? Okay, you try on the side. I don't know. Yeah, come on. At least we listen. She's like, okay, now I am in demand. Everyone is looking for me. Okay, so last class we had done permutations. Hopefully, guys, you are there online. Murli must be there. Sham and Hari. What happened to Hari Hari? Why is it not? Oh, sorry, Hari Raghav. Hari Raghav. This is, by the way, this is a very nice book. You know, the chemistry version of ABC. I have studied that in 11th standard, and I really like it. This is 11th standard. This is physics, no? I'm talking about chemistry. I studied. See, when I was in 11th standard, so I didn't know. Acha, Disha. A lot of books are there, right, nowadays. Have you ever turned pages of these books? No, right? Turned pages. Then I don't know. See, the thing is, it's not much in order, or you know, it's very cluttered. Masker. Not me, okay? I'm not responsible for that. Okay. Where is the location of? Okay, so in previous, yes. Not wait. First, let me just let me add pages first. So how is your chemistry? What happened to ma'am? So she she left. Okay. Bhaskar sir left. Oh. It's like Bhaskar is just there. I thought maybe the ghost of Bhaskar, Christmas carols and all that. Is it or not? Mr. Ashwin. Wait. I'll share. Wait. Let me add some pages first. Okay. See, I think permutations, most of the problems are you able to solve? Have you tried? See, that's the question. Have you tried? Are you able to solve problems? The fundamental principle of counting, is it clear? Means that when you multiply, when you add, is it clear? It's all about the statement, Ashwin. Okay, Murli and all, whoever is there online, I'm not talking to them. So Ghushal or both biology, any doubt? Sab changa se. All right. Oh. Okay, so circular permutation, I think we haven't done circular permutation, right? When right now we have done only linear permutation, that means the objects are arranged only in a linear order. Okay, like a number line. Now you bend the number line. Like when do you bend the number line? Do you know that? Have you studied that part in physics? No? Okay, maybe you will study it. Have you studied the cross multiplication? Cross product? What is cross? What do you mean by cross product? Everyone else. Okay. Let me share screen. Shut up. 1, 2, 3, 4. See? Okay. So what is cross product, by the way? Yeah, we are talking about cross. Why it is called vector product? One. It's like, yeah, it's, just imagine 4 people having a sword and just hit you. It feels like that. Yeah. Why is it called cross product? What do you mean by cross product? Ashwin, ask your friends. Those are my friends too. Yeah. So why it is called cross product? Because we write cross product and dot product, 2 products you have studied, right? So why it is called dot product? Because good. It is also called vector product, right? Why it is called vector product? One. Why it is called vector product? That means you mean a cross product of 2 vector is a vector quantity. Can you give me an example? Huh? Torque. Okay, torque you are saying. See, that's why you should not have filter in front of you. Don't worry, your voice will be polarized. Don't worry. You know what's polarized? No, I haven't studied yet. No, it's do you have what type of specs you are wearing? Is it polarized glass? What is the meaning of polarization? No idea. No idea at all. In 9th standard, I think you have that chapter sound waves and all, right? Why do you keep deleting Ashwin? See, don't delete questions here. If you delete, I will write a letter to CBSE. Please don't delete questions. People are not studying; they are enjoying a lot. Let's put polar what? Film. Okay. Say film what? Bollywood, Tollywood, and Hollywood. Okay. See. Okay, when you will be studying in physics that waves and thermodynamics is there, right? That time you will be asking, okay, he was right. He was teaching us graphs. So that time you will realize why graphs are so important. Like, see, there is something called fast Fourier transform. Okay, we use those type. Let's study permutations and combinations. Okay, circular permutations. Sometime vector product is what? We'll see. We'll see today. Okay. Nice. I like that. What was that, by the way? No, I just heard blah, 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 blah. That's what I heard. Because all of you 4, see, your wave is like this, her wave is like this, her wave is like this, and together it will be that. See, ECG and all, it all works on fast Fourier transform. That means you will separate all the waves. You can study all the individual waves. That. Sign? See, that's how you combine all these graphs and you will get stupid graphs. Okay. What? Okay. See, till now we have studied permutation in this order. Okay. Now we are going to understand permutation in this order, circular order. What do you mean by circular permutation? What? Means it should be a closed loop. till now, whatever we have studied is an open loop. Okay. Integration you have studied a little bit, right? You have two symbols in integration. One is this and one is this, right? See, the second one meaning is integration in a closed loop, adding in a closed loop. Okay. And the third one is adding in open loops. Okay. That's the meaning of, you don't have to write that. Please don't do that. Not, see, I don't, yeah, integration is in 12th standard, so I'm not going to teach you that. Anyway, okay. So linear permutation, and permutation is arrangement of numbers, okay, or arrangement of orders. So whenever we write NPR, what's the meaning of NPR, Ashwin? Yes, what is the meaning of NPR? You are trying to make hair like me. It will never happen. Your dad, he will chop it up, or maybe your teacher. Right now, I don't have anyone to judge me. Tell me, what is NPR? No, actually, I went to school and they'll be like, sir, if you were in my class teacher will hold your hair and she will chop there itself. I was like, that's why I'm not in school right now. Yeah, you tell me. What is NPR? What is NPR biology? Second biology. I don't know. Don't say I don't know. See this pencil? What is NPR? Yeah, what is NPR? Share. Number of? Wow. 4 classes of permutation. Anybody knows how to say it? How many times I've written that in class? Is it there in this class? I'll show you.
Sir, arranging n number of objects in R ways.
Murli is saying something. Wait. Yeah, Murli.
Arranging n number of objects in R ways.
Arranging R number of objects.
Yeah, yes, sir.
What? Do you everyone have your NCERT book? Open it. You are coming from school, no? So you must be having the book. What? Tell me what NPR is. What's the meaning of NPR? One at a time. Yes. What's the meaning? Arrangement of, yeah, permutation means arrangement of n R at a time, right? How many times we have done that in class? That's what we have been solving all the time. Huh? So NPR we write as n factorial upon n minus R factorial, right? Fine, Ashwin, till now it is okay. See, that was in linear order, okay? In linear order, we used to do this. But what happens when we arrange objects in circular order? Okay, what will happen then? Now, let's take, that is the closed loop. What can be the example of closed loop? Yeah, like a round table conference, okay, or the beads of a necklace, right? Different colors you are using there. So how many ways you can make a different necklace, let's say, okay? So those are just examples of your circular permutations, right? Permutation is simple. In permutation, order matters. Remember, order always matter in permutation. Like A, B, and B, A are different permutations. But these are not different combinations that we are going to see. The combination is same, isn't it? Okay. So let's say there are three objects. Let's say A, B, and C. Okay. Either you are going to use clockwise direction or anti-clockwise direction. Any one direction you are going to use for counting. Because if you are changing the order, if you are changing the direction, that means you are changing the order itself. Okay. Either we'll go this side or we can go this side. Usually, it's recommended to go in anti-clockwise direction because mostly we do that. Okay, like in cross product also that we will see the example. We always go in anti-clockwise direction. It's not a hard and fast rule that you have to go only in anti-clockwise direction. But always, if you have taken it once, you will always have to consider anti-clockwise, or if you are taking considering clockwise, so always you have to go in clockwise direction. Only one direction you have to go. Okay. So since it is in the book, it has been taken anti-clockwise direction. That's why only I'm taking anti-clockwise direction. Okay. Now, if you have three objects A, B, C, how many ways you can arrange these three objects? How many different ways you can arrange? First, we'll see examples. Okay. How many different ways we can arrange? Either it can be like A, B, C. This is already one. Another, what it can be? What can be? Say it. It's fine. BAC. BAC. Okay. BAC. All right. Anything else? CBA. Okay. CBA. That's what you're saying? Why, okay. Anything else? ABC is already one, no? ABC. See, okay, you have to take consider only one direction. Okay, either clock. Right now we are doing clockwise direction, right? Okay. ACB, but okay, let's write ACB. Whatever you are saying, I'll just keep writing ACB, right? Okay. Yes. Anything else? See, we'll see the difference. Just keep telling what all combinations that are for BAC. Okay. BAC. Okay. Anything else? Okay. C. Okay. Anything else that you feel that it's left out? CAB or BCA, whatever. BCA. Okay. BCA. Anything else that you can think of? I think I should. BCA is going anti-clockwise. See, we are always counting in this clockwise direction. These are all clockwise, right? These are all clockwise direction. It's fine, we are just trying to understand it here. Okay. Now you see, first one is A, B, C. Fine. Second one is B, A, C. As you say it, B, A, C. Okay. Third one is C, B, A. That's what you're saying? Okay. A, C, B. Okay. B, A, C. Okay. B, C. Just because first I wrote this point, you all have considered this point as the fixed point, right? That's what you guys are doing, isn't it? But just see this. A, B, C. Right? A, B, C, you are writing A, B, C. This order you are writing A, B, C, right? Now you see this one. Okay. A, this last one, A, B, C is the same order. You see, this is also A, B, C. This is also actually A, B, C, right? You cannot fix one point, right? The order is same, right? In the circular table, it's not like you have fixed a position. You see that A, B, C, and B, C, A. Just writing B, C, A, B, C, and B, C are in same order. In same order, it is. The order is not changing, right? It's after A, there is B. After B, it is C, right? Now you see the difference in circular permutation and open loop permutation. This is closed loop permutation, right? Even though you are writing, see, if it was linear, if you break the chain from here, let's say you break the chain, then you can write this is A, B, C. Let's say you cut it from here. Then it is, you can arrange like A, B, C, A, B, C. And the last one, you cut the chain from, then you can say B, C, A. Then it will be different. The linear permutation is different. But the circular arrangement is same, right? Circular arrangement is not different. It is the same order. A, B, C is going in same order, right? That's why whenever you are solving a circular permutation, what we will do, we have to fix either one of the number, and then we do permutation, arrange the other numbers. Okay, like if you fix A, then you can interchange B or and C itself. Then it will be it will have some different order. Like, okay, I'll name this number 1. Number 1 and number 6 are same. Fine. Number 2. Okay. Number 2, what order it is following? A, C, B. Anything else we have? A, C, B. See, this A, C, B, and this is also A, C, B. See, if it was linear, then it is, you can say, okay, we start from B, but we reach C, right? You can say that, like you cut the loop from here. Then it will be B, A, C, and this will be your A, C, B. But here, see, it is reaching the same point. A, C, B, or let's start from here. C, B, A. Okay, and this is also what? C, B, A. If you are moving in a circular table, the order of sitting, let's say these are 3 persons, the order remains same. After this, that person will sit after A, you have C, then after C, you have B. That means 2 and 4 are same. 2 and 4 are same, right? Now again, you see this one, C, B, A, and this one. After C, you have B, then A. After C, you have B, then A. Both of them. C, B, A, C, B, A. The order is same. That means your third one and the fifth arrangement. So third and fifth arrangements are also same. Understood this thing? If it was linear permutation, if it was just a linear seat, 1, 2, 3, you will just write 3 factorial, right? So the permutation will be 3 factorial. But here, what you see when you have circular permutation, 3 seats, what you are writing? 3 minus 1 factorial, that is 2 factorial. Only 2 different arrangements you will be getting. Okay, right? Understood? Yes or no? See, I'm just, no, if it's not, then I'll explain you again. First, I'm trying to give you example, because then I'll be writing in terms of n. It's just, now see, what I'm trying to tell you here is, whatsoever number is there, okay, you just fix, like suppose you have, in a clock, you have 12 numbers, right? 12 numbers. You fix one of the number anywhere. If you can fix one, that means it is reaching back to that same position. That's why you need to fix one. Okay, anyone you want to fix, you just fix one, and others you can arrange. Okay, like if you have in a clock, with or without sense, how many, like you have 12 numbers, right? 12 objects, let's say. You have 12 objects. You fix one of the objects. That means now how many objects you have? 11 is remaining. If you fix one, that means all 11s can be arranged in 11 factorial ways. Okay, so always in circular permutation, you will, what you will have, instead of n factorial ways, what you will be having? N minus 1 factorial ways. Okay, if there are n number of objects. If you have n objects. So these are the possible arrangement. This is linear permutation. This is your circular permutation. Understood why it is 1 less always in circular permutation? And factorial it is. It's not just number 1 less. Okay, because all other 11 can be arranged in 11 factorial ways. You have to fix one point because it is coming back to that point. Okay, and see, the thing is, if you count as clockwise and anti-clockwise both, it doesn't make sense because the order, you are completely changing the order. Okay, so in one particular order, or if you just want to count both, you multiply it by 2. If some question is like that, but it will not be. So let's solve some of the problems based on this. Easy it is, right? It's not that tough. And you understood or not? Understanding is more important. Why we are subtracting 1? If you have 12 objects, why we are subtracting, or why we are having 11 factorial ways. Okay, so that is important. We'll come cross product, don't worry. See, if you won't fix one point, the thing is, come back to that same example. If you won't fix any one point, what will happen? You can keep writing, you can fix A, B, C is there. If you are not fixing this position, you count the number of arrangements. You count the number of arrangements. A, B, C is one possibility, A, C, B is another possibility. Other are just repetitions. You can write B, C, A, but again it will come back to that same position. That's why we have to fix at least one. At least means you have to fix one. If you can fix one, then others you can arrange in means whatever ways you want. Others will be your linear linear permutation, right? Again, if you take this A also, if you won't fix this point, it will keep repeating itself. Okay? So same permutation keep on repeating, same arrangement keep on repeating. Like you can write A B C or C A B or B C A, all are same, right? It is coming in same way. So these three numbers are not different. These three arrangement are same. Like you are sitting here, is here, and we are three are making a kind of circle, right? So you, if you go clockwise, let's say this is your clockwise direction. So if you go clockwise, we are always in that same order. She will always be on my right, and he will always be on my left. Same with her. Either you start counting from him or her or me. It will be same. It will remain same, right? With respect to if you fix me, he will always be in the left. She will always be at the right. Okay? And with him also same thing. But in linear permutation, I'll just sit in the middle. Okay? So her left side will be empty. His right side will be empty. Okay? So that means we have three positions and three positions can be filled. We can arrange, we can shift like this here, here, here. Right? But when you are circular, the order will remain same. Even if you just keep changing, even if you start counting from here or from here. That's why you have to fix one in circular. Is it okay? You understand why do we have to fix one? Because the order you need to keep. Okay, so let's do some of the problems based on this. I think is circular permutation in NCERT. Do you have some problems? You don't? Wow. Why we don't have any problems in circular permutation? Okay, find the number of ways in which 7 dissimilar things can be arranged in a line and in a circle. Okay, I'll write the problem here. Find. You have to find the permutation, and in short, I'll just write find permutation of 7 object. This 7 obviously dissimilar. It has to be even 7 different objects. Number 1 in line. Number 2 in what circle? Do this. In permutation, is repetition is allowed? If you are repeating, that means you keep filling with that same person. Here it can be A, B, 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 C, C, C. Those combinations will be there. But once A is taken, you cannot have A at 2 places. So that is not possible. Okay, that will come under permutation of repeated when repetition is allowed. That is different permutation. We have solved that in fundamental principle of counting while studying. Yeah. In line means you have. Yeah, so why it will be 7? Because you have 7 places, right? You have 7 places. In this one, it can go in 7 ways, 6 ways, 5, 4, 3, 2, 1 ways. So that will be equal to 7 factorial ways. In circle, it will be 7 minus 1 factorial. Because you have to fix one. If you fix one, so it will be your 6 factorial ways. Easy? It's easy, right? Okay, do one more problem. Okay, so you have got the. In how many ways can 10 beads? You have got 10 beads of different color. Wow, 10 different color. I thought there were only 7. Form a necklace. Form a necklace. You have to find the permutation or arrangement. Necklace means closed loop, right? When you are making a necklace, that means it will have to be a closed loop. It's easy, right? 9 factorial. Okay. So why it is 9 factorial, Ashwin? Huh? 10 minus 1 factorial. Why 10 minus 1? Why we are subtracting 1? You have to fix one. Okay. If you fix one, you are left out with only 9 of the beads of different colors. Okay. That's why it is 10 factorial. Yeah. Round table. Okay. Round table conference also will have questions. Okay. There are 6 gentlemen and 4 ladies, of course. Why not? So 6 boys. Let me write boys, because not gentle. They are not definitely gentlemen. 4 boys. Sorry, 6 boys. Sorry. My mistake. 4 ladies. Girls. Okay. You like girls? Okay. What? Okay. Boys and girls. All right. Now they are having dinner together. Yes. Okay. In how many ways they can set themselves so that no 2 ladies are together? Find the permutation. Find the permutation. See, instead of permutation, it can be written arrangement, right? You know that. No, it is round table. Round table it is, obviously. That's what we are studying, round table. Find the permutation of what? How many ways they set themselves. Why ladies are not together? I can see 3 ladies are together. No two. See, that's why men always want to separate women, right? Ladies, is it? Because they stick together. And the men will be like, I can separate you guys. No, that is not true. I'm just blabbering. Okay. Don't. Okay, I have a very good handwriting, so please excuse me for that. What? Homework. See, if that takes a lot of time, and the problem is if I won't write it, you will just not do and say, sir, that was cluttered. I didn't understand. Anyway, nobody is doing that. Right? You did? Don't blame on others. See, the thing, that's why I stopped giving you assignments. You guys are not doing it, so just do your NCRT exercise. Ask me next. See, I've been given a chair, a table, so I have to make use of it. Find out. See, this is kind of similar problem, right? We have done in linear order. In linear table, we have done. Okay, and now you do it on a round table. What? Something is there. Ashwin, you heard what she said. You are only my ear and eyes. Okay. Do it first. Then we can laugh together. We have combinations also. Yeah, I heard that. Don't scold me. Yeah, Ashwin, what happened? See, first, always, I'll just give you a hint. I know everyone is blah, 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 blah. I don't know what is going on between you guys, but it's a circular table, right? If ladies are not to sit together, that means gents can sit together, right? They can sit together. It doesn't matter. So arrangement of boys doesn't matter. You have to arrange girls. Just think about it. That means if this is one girl and this is another girl, there must be a boy in the middle. Okay. Let's say G1, G2. There has to be a boy in the middle. It can be one boy or two boys, but there has to be at least one boy. Now think in that manner. We have done that in linear order we have done, right? So try to do that in the circular order. How many boys are there? In how many ways the boys can sit? So you got the answer. Almost you reached there. 5 factorial. Let's say B1, 6 boys, right? B2, B3, let's say B4, B5, and B6. Okay. These are the 6 boys. Okay. That means they can be, they can sit in how many ways? So boys can sit in 6 minus 1 factorial ways. So that is equal to your 5 factorial ways. Boys can sit. Now in girls will have basically either here, or here. Okay. These are the positions available for a girl. So how many positions are available? 1, 2, 3, 4, 5, 6 positions are available. But how many girls are there? 4 girls. So how many ways it can be arranged? Do it. Now this too much hint I'm giving. This is not hint. This is practically solving your problem. Why 5 factorial? See, these are the 6 main ones. See, boys are already you have done in 5 factorial ways. N minus 1 factorial ways you have already done. So circular order is done. Okay, that means you have already done the circular order. That means how many positions are remaining? 6 positions are remaining. So ladies can sit or girls can sit. Seat. Okay, seat. Or let's write sit, whatever. ED. Okay. I am not teaching English grammar. And I'm very bad at it. I know. You don't have to point it out. So either the girls can go here. They have 6 positions, right? And only 4 girls are there. So if girl 1 is going here, and that means how girl 1 can go in how many positions? 6 positions girl 1 can go. Second girl can go in how many positions? 5. Third and fourth in 3. So these many, that means this is what? 6p4. Right? So 6p4 ways the girls can sit. See, circular permutation you have already done there. See, biology 2. I know you are having trouble. See, circular permutation you have already finished. Now it's exactly similar to linear permutations. Once circular permutation is done, you are now solving linear permutation. If it was linear permutation, it will be 6 factorial into this. If it's right, just do it. So girls can sit here. That means 5 factorial. So total number of possible arrangement. So total. Yeah. Don't kill that mosquito. Total possible permutation or arrangement will be. How much is 6 into 5 into 4 into 3? 720. And 5 factorial? 120. So possible is 120 into 360 ways. These many ways. Suppose this was linear table. It's just a bench. Okay. Now suppose this is, let's say, part 1. Okay. First part, this one. Now let's say second part. If the table is linear, if the table is linear. Linear means straight table. It's okay. Let me add some pages. Add of the page. Okay. So how it will be? One. So total, how many positions are there? 6 plus 4, right? 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 to total people are there, right? So let's say if the first boy is sitting here, right? So these are the 6 boys, right? These are the six boys are there in total, right? Girls can have how many positions? In between one boy, at least one boy should be there, right? So how many positions girls can occupy? 1, 2, 3, 4, 5, 6, 7 positions, right? So it will be 7 into 6 into 5 into 4. There are 4 girls only, right? So these many girls can sit like this way. Right? Arrangement of girls, right? And arrangement of boys. What will be the arrangement of boys? 6 factorial ways. Okay, so total permutation will be this multiplied by this. We have done same thing here also. See in circular permutation. But in circular permutation, the available positions were how many? 6 only. 1, 2, 3, 4, 5, 6. Girls can sit only in either this 2, 3, 4, 5, 6. Because again the same it's a loop, so it doesn't has an end point. It is not having an end point, right? That's why we are fixing one boy first. You fix one boy, so how many other boys can sit in how many ways? 5 factorial ways, and then girls will have 6 positions to go. Okay, so 6 into 5 into 4 into 3, because there are 4 girls. Got it? Biology. So understood the difference between linear and circular permutation. I think that will be enough. Because if you look into English statement, it can be and. It's an and statement, right? Boys and girls will sit. So this is the possible arrangement of boys, and that is the possible arrangement of girls. That's why we are multiplying. If it is like either boys or girls will sit, then it will be, you will be adding that. Okay, got it? It's just English statement. Maybe any doubt? No? All right, so we'll come to combinations. I think permutations you'll be able to solve all the. See, this question can be there in your CBSE final exams. Okay, circular permutation. I don't know if it is there. They are asking in your school or not. Have you solved problems on circular permutations before? It is. It will, because we had 2000. I think 2002 or 6. Not, I'm not that old. Okay. Yeah, 2012. I have taken CBSE exam. So that time it was there. What? Any doubt? Okay. So combinations. Permutation is clear, right? This is all about permutation. So permutation, we'll see some of the introduction of combinations. Okay, and tomorrow I think combination 1 class is enough. After today, only tomorrow we can finish combination. See, permutation, why it was important? Because order matters. We'll see how order, what is combination. Ashwin, you have to ask again and again. What? Huh? Spelling mistake? Yeah, that's what I'm saying. You are not even looking here. These two guys are busy in themselves. Girls stick together, right? Have you heard that? I have heard it so many times, and I was like, yes, okay. Please, don't kill me. Okay. Nice, good, nice diagram. Then Then show. Okay. Combination is just selection. Okay. Ways of selection. Order doesn't matter. Okay. Order will not matter in selecting. Like if you have, let's say, three, I'll just take example of three because it is easy to understand. Okay. Suppose you have a banana, a pear, and an apple. Okay. These are the three fruits that you have. In how many ways you can select this? If you have to select only two, you can select either a banana and a pear, right? You can take a pear and apple. You can take a banana and apple, right? So these are the possible ways you can select. Now, if I ask you to arrange, wait, that's what I'm telling you. See, these are the, see, that means these are the possible ways that you can select these three fruits. Just don't go with permutation combination level. Just imagine you have three different color of pen: blue, black, and green. Okay, and you have to choose only any two. You can take any two, right? You can take any two. That's what the meaning is. Just take pen. I think you guys don't take fruits, so don't take fruits, no? Morning idli sambar, evening vada sambar. I like idli vada sambar. Awesome. The combination is awesome, right? Do you take in the morning? Always, when if I'm awake till 2 o'clock somewhere, so what will happen? There is a really nice shop in my street, okay, and his sambar is so tasty, and he starts from 7 o'clock. It's 4 o'clock. The shop will open. Okay, you guys are not invited, by the way, because nobody is laughing. So the thing is, I'll just wake up. Means I have a class from 6 to 7. Okay, in the morning. Yeah. So what I will do, I'll just be awake till 4 o'clock. I'll be doing something, maybe playing some online chess or watching some documents. Something I'll do. I'll take the class. I'll go there. I'll eat properly, like today. And again, I'll have a very good sleep and wake up at 1 o'clock. See, that's the advantage of not living with your parents. In my home, I don't know why. Even if I'll sleep at 5 o'clock, I'll wake up at 6 o'clock. Again, I'll take breakfast. I'll do everything, and again, my dad will go to work, and I'll just go in my bedroom and I'll sleep there. But somehow it is like my dad is always like, even if you have cancer, he'll be like, just get up in the morning, everything will be fine. Yeah, he's like that, right? All parents are kind of like that, and they are kind of right, not exactly, but still they are right. Let's study combinations. So see, you have three pens. Okay, so one is your black pen, your green pen, and a blue pen. Okay, blue is again same. Red. Where is red? Where is red? Red. So we have a red pen. So you can, if you have option, you are in a hurry, you just pick any two, right? You can pick the combination of blue or black and red. Okay, one combination is this: green red or black green. These are the possible combinations you can pick. But if you have to pick in order, it matters. What? Why you are laughing? Something. See, if it's like if you are distributing the pen, if you are giving it to someone, okay. So first pen you are giving black, and second pen you are giving red. So so black, red, black. Like these are the two permutations. These are the arrangements, right? These are two different arrangement of numbers, right? So first you are picking blue or black, whatever, black and red. then the next can be either you can pick red first and black later. See, this is the first position, this is the second position, right? So first you are picking up black, then red. Here what you are doing, you are picking red and then black. So this is permutation, right? This is your permutation or arrangement. Here order matters. First, why order matters? First, you are selecting black, then red, and then one more selection. Sorry, one more arrangement can be red and black. Those are the two different. The combination is same, right? The two pen, if you are keeping it together, they are same, isn't it? So the combination is only one. This one. What's wrong with this pen? Right? The combination is same. So for this, we have two combinations, two arrangement for this. This can have two arrangements, right? If you are picking two at a time, so together they can be arranged in 2 factorial ways, isn't it? And total they can be arranged in 3 factorial ways. These are the 3 pens you can arrange in 3 factorial ways, isn't it? And if you just have to select, you can select only in 3 ways. Right? So you are getting the idea what's the difference between permutation and combination. No? Okay. I'll explain a bit. At least you are listening, right? You are listening, no? Okay. Try to understand this. Like you have 3 pens. Okay, 3 bananas or no, some 3 fruits, something 3 colors. Okay, so let's say you have one pen, one eraser, and one what? Pen, how you will sharp your pen? Okay, let's say this is a pencil. Pencil is fine, right? Pencil and a sharpener, right? So if I just ask you to pick any two, right? That means select any two, I'll give it to you, right? So either you can pick a pencil and eraser, or you can pick a eraser and a sharpener, or you can pick a pencil and a sharpener, right? These two you can pick. But I ask you to pick in an order, in a particular order. This is not an order, right? In a particular order, if I ask you, so either first you can pick pencil, then you can pick eraser, or you can pick eraser, then you can pick pencil, then you can pick eraser and your sharpener, then again another sharpener or eraser, again pencil or sharpener, or sharpener. Why I'm not able to erase this? Eraser, right? What is that? This was pencil and sharpener, right? Sharpener and pencil. So now you see you're picking in a particular order. Here you see order matters, right? In which order you are picking. So those are the two different events. See, for this, these two are the same event when you are just picking, when order doesn't matter, right? These two, see here, right? In the first one, you see order doesn't matter in which order you are picking. In second one, order matters, right? Because you are picking first pencil, then sharpener. Here it is first sharpener, then pencil. So this is a order, particular order you are picking up. So these are called arrangements or permutations. Permutation or arrangement. Here order matters. Here it is called combination or selection. You're just simply selecting. Okay, order doesn't matter. Okay. Have you heard Nityanand? Money doesn't matter, huh? Have you heard him? Nice guy. Really nice guy. You should listen to him every day. Don't tell your parents I'm saying that here, listen to Nitya. I have said nothing for the record. I meant nothing. Please don't send me to jail. What? I don't know what these guys are talking about. I don't know these people. Okay. So understood was, listen, now you understood the difference between permutation and combination. Okay. That means combination is represented by NCR. That means combination of n objects taking R objects at a time. Write down selection of n objects taking R at a time. Okay, and we write combination NCR is equal to n factorial upon R factorial n minus R factorial. Okay, permutation, how do we write? NPR n minus Bhaskar. Where is Bhaskar? N minus R factorial. Now, see, this is, let's say this is 1 and this is 2. So, what's the relation between a permutation and a combination? Can you find it from here? Just substitute equation 1 in 2. Right? Yeah. Do stop blabbering and write. This. Like I don't know. Huh? Nidhi? Got it? Yeah, you're correct. Don't worry. I blabber a lot. So NPR is equal to, see, NPR is n factor. Now, see, this is your NPR. See, this is your NPR, no? Isn't it? So NPR, if you multiply it this side, what you will get? R factorial into NCR. That's what you will get. No? Biology? No? No? Okay. All right, she's right. It's fine. I'll show you magic trick. So, see, it's because the surface. See, again here some mathematics is there which I'm not going to teach you. See, NPR we can write NPR is equal to n factorial upon n minus R factorial. Okay, let's divide it. Better doing that instead of substituting. Just divide 1 by 2 or 2 by 1. Divide 2 by 1. What you will get? NPR upon NCR is equal to n factorial upon n minus R factorial divided by n factorial upon R factorial n minus R factorial. Fine. Is this okay? Can we write this as n factorial upon n minus R factorial multiplied by R factorial n minus R factorial upon n factorial? Is it fine? This is 1, n factorial by n factorial 1. This is what? 1. What do we have? Only R factorial. So NPR is equal to NCR into R factorial. Is that okay? Fine. Now the examples that I just gave you. Suppose you have n is equal to 3 and R is equal to 2. Right? N is equal. So find out NPR is how much? NPR is how much? 3 factorial upon 3 minus 2 factorial. How much is that? 3 factorial or 3 into 2, that is 6. Fine. Now find NCR. NCR is equal to 3 factorial upon 3 minus 2 factorial upon 2 factorial. Fine. So this is 3 into 2 factorial upon 2 factorial, which is equal to 3. Fine. Now see the relation between NPR and NCR. Just I gave you. See here how many combinations were possible. See 1, 2, 3, 4, 5, 6 combinations. Sorry, 6 permutations are possible, right? or 6 way we can select it. 6 way we can arrange it. Sorry, the correct way is the 6 ways we can arrange it, and how many ways we can combine it? 3 ways. Fine. So you see the same relation that we are taking it here. 6, 3. Okay. And you just if you want to check this relationship, this equation, let's check this one. Let's say 8. Okay, we can check this one as well. So NPR will be equal to R factorial upon NCR, right? So let's find the value of R. So NPR, how much we have got? 6. R factorial, how much we have got? 3. So R factorial is equal to 2. That is again 2 factorial. Fine. That means the value of R is equal to 2. R value is 2. Fine. Do you agree or disagree? I'm just doing some simple calculations. R is equal to 2. Right. So see, in this problem, we are taking 2. We are trying to arrange 2 objects at a time. Right. We are given 3 objects and we are arranging 2 at a time. So what we'll get? 6 ways are possible. When you are selecting 2 objects at a time, you have 3 ways. Okay. So that's the difference between permutation and combination. And if you have understood permutation, you can solve all the problems from combinations. But anyway, we are going to solve some of the problems tomorrow. Is combination clear to you? I think if you have understood permutation, combination is easy, right? See, combinations, next class, just try to find out some of the examples of combinations, real life examples of permutation. You have asked real life example of logarithmic function, right? Why do we use logarithmic or exponential functions? You asked, no? Who asked that? See, I told you, logarithmic functions are used to, to compress the value. What? Okay, I'll stop. What? Okay, still you want to know. Okay, I will give you. See, logarithmic functions and exponential logarithmic functions are used to compress the values. Okay, like the earthquake, which scale do we measure it on? Richter scale, right? So it works on that sound frequency, decibels, the amount of sound what you are listening. So that all works on what? A logarithmic scale that we are using. So what we do, we compress the values. When we want to study, very small values, what we do, we try to expand that value. So we do that using exponential. So that's the use of exponential, or just studying the population. In biology also you will have that same relation, population density of maybe bacteria or something, or like population density of a particular area. How do we study that? We use exponential functions for that. Okay, so these are some of the examples. We have like a lot of examples. So similarly, you try to find out the real life example of permutation and combination. Okay. Thank you. But you just try to find out. I told you combine permutation as well as combination. I never, separated permutation example and combination example. I just want you to separate those and find out the real example of permutation and combinations. Okay. Thank you. Bye. I'll end the class here. Thank you, guys. Those who are on.
Thank you, sir.
Thank you so much. Try to come to class tomorrow. We'll finish combinations.